Alright folks, thanks for coming. There's a little change in plan. I realize I haven't covered linear inequalities. I think the best time to cover it is now, since we just finished linear equations. Okay, linear inequalities is it's the same as linear equation, except that we introduce the concept of less than, greater than, less than, or equal to, greater than or equal to. Okay, but you will see it's almost the same thing. We're gonna use to actually graph a linear inequality. You have to use the concept of a linear equation. See, so this is the best time to cover this idea. We're gonna cover it in more detail when we go to algebra 2. Okay, when we go to algebra 2, we'll still have the opportunity to cover this in more detail, but I need to introduce it here, and then after that we'll move on to exponents and polynomials. Alright, so this is just gonna be this one video. Will cover it and then we'll move on. It may be long because after I give you the concepts, I need to solve a lot of problems. That way it will help you to understand the concepts. Okay, but anyway, before we continue, just subscribe to my channel, like and share this video. If you have any comments or questions, leave it under this video. Okay, but anyway, let's try to understand what does it mean to for an expression to be linear inequality. That's what we need to go ahead and understand. Okay, all right, so the question I have for you is, what is an inequality? When they say two things are unequal, what does that mean? Well, some books will tell you that an inequality relates algebraic expressions, right, using such symbols as less than. That's less than here, less than, greater than. Okay, this is greater than this one right here, or let's see, less than or equal to. Okay, and this one is greater than or equal to. Okay, all right, so some books will say inequality is an expression that relates to it has to be two algebraic expressions using such symbols as less than, greater than, less than or equal to, greater than or equal to. But see, that doesn't tell you, that kind of makes sense if you already have idea what they're talking about, right? But most people don't have idea what they're talking about, you see, when they speak this math language. So what I'm gonna do is I'm gonna make sure you understand it. Yeah, you have to understand it before you leave here. After watching this video, you have to understand it. Okay, now inequality has to do with the concept of order. Let me write that down. Concept of order. Okay, I'm gonna break this down. I'm gonna go to its root. The concept of order. What does that mean? Well, you remember, you gotta go back to Cartesian coordinate system. Let me show you. Cartesian coordinate. It's like that. Remember, we talked about that. This is 0, 0 here. The point here is 0, 0. Then you have 1, 2, 3, 4, right? Keep going. And then you have -1, -2, -3, okay? And then you have in the y-axis, this is x-axis, this is y-axis, you have 1, 2, 3, okay? And then you keep going here, -1, -2, minus 3. Okay, you keep going down. Okay, so basically notice that this, the x-axis is reproduced in y-axis. So what I'm gonna do, I'm gonna use one of them. I'm just gonna use the x-axis. Okay, let's use the x-axis and move on. So we use the x-axis. That way I explain to you what is the concept of order. So let's draw a segment of the Cartesian coordinate. We'll draw a segment of it like this. Right here is 0. Okay, I'm gonna choose any number. Okay, it doesn't matter, you can choose whatever you want. Let's say this is okay, let's say this is 4 here, and let's say this is just, I'm choosing the random number. Let's say this is 7. Okay, now we're on the x-axis alone. Let's say this is minus 3, and let's say this is minus I want to choose completely different numbers, minus 6. Okay, and look at them. So look at them. When you look at them, right, that thing shows the relation. It shows what they call order relationship, the concept of order. You see, order relationship, okay, between the numbers. That thing shows order. See, you need to understand. It's very simple, but you have to understand it. It shows order relationships between the numbers. Okay, now notice something. Notice that in this Cartesian coordinate system, notice we can keep going to the right. You get 20, 30, 40, 2,000, 10,000. On the left, you can keep going, get less than 10, less than 20, less than 30,000. Okay, notice that as you move from left to right, the numbers get bigger. 7 is bigger than 4. 4 is bigger than 0. 4 is bigger than minus 3. You notice that, right? 0 is bigger than minus 3. Minus 3 is bigger than minus 6. So if you go towards the right, look from left to right, the numbers always getting bigger to going towards the right. And if you go towards the left, they're always getting smaller. That's what they call the order concept, the relationship between numbers. The order, the way they order the number, ordering of the number. That doesn't mean that the word order. Don't let the word order throw you away, throw you off. This is the way they order the number in the Cartesian coordinate system, what I call the real number system, the XY coordinate system. Okay, from left to right, the numbers get bigger. Okay, see their position of the numbers in the system. 0 is less than 4. You see that, right? 4 is greater than 0. 7 is greater than 4. 7 is greater than minus 4. Well, minus 3 in this case. Minus 4 is somewhere here. Okay? Minus 6 is less than 0. Why? Because minus 6 on the left of 0. 4 is greater than 0 because 4 is on the right of 0. You see that, right? So this is how they order the stuff. The ordering system, the ordering relationship introduces the concept of less than, greater than, less than or equal to, greater than or equal to. You see that, right? Greater than or equal. That's where you get that from. Notice this. That 0, well, I said it before, 0 is less than 4. Right? That's how you write that. Because 4 is greater than 0. You see that, right? That's another way you can read that. You can read this thing here. You can read that. Look at that carefully. You can say 0 is less than, 0 is less than 4. Make sure you understand that. Or you can say 4 is greater than 0. You see that, right? See, if you read it from right to left, you see 4 is greater than. You see, so sometimes they switch it around. You can write this as 4 greater than 0. So to make sure you understand that it doesn't matter how you switch it around. So that's what is going on there. And then look at here. 3 minus 3 is less than 0. You see that, right? Now, what of this concept of less than or equal to? Well, you can say 4 is less than or equal to 4, which is true. Right? 4 is less than 4. It's not true, but 4 is equals to 4 is true. So you can write it like that. 4 is less than or equal to 4. Any number can be less than or equal to itself. Yes. So I hope you can see that. You really need to understand that. You see, the value of a variable may be unknown, right? But you may know that it is greater than or equal to another number. So what they say in there, let's say this is a variable. We don't know the value. It could be 6, it could be 7, okay? So if we say x is less than 4, we say x is less than 4, what we're saying is x is over here. X is going down this way. So make sure you understand that. So when you see this expression, x is less than 4, all they're saying is if you come from 4 here, x is not quite 4. So you see that x can be anything going to the left. Supposing you say x is greater than 4, right? That means 4 is over here. So that means x can be anything over here going that way. X can be 2000, x can be 7, x can be 9. So this is a variable. X is a variable, right? Okay, supposing you say x is greater than or equal to 4, right? That means 4 is included. You include in 4. X could be 4. Or x is greater. That's why they say or. You remember when we describe that, we say or. Let me say or. The word or right there. X is greater than or equal to. So x is greater than or equal to 4. Means x is 4 and it can be greater. That's all that is saying, man. Don't get caught up in the language. Just make sure you understand what all these things mean here. All these symbols, sorry. Make sure you understand all these symbols, man. Less than, greater than, less than or equal to, greater than or equal to, okay? So, yeah, when you say x greater than or equal to, it means 4 is included. It can be 4 or it can be greater. Alright? So that I want to make sure you understand that everything goes back to Cartesian coordinate system. Alright? So, but anyway, let me give you a couple of examples. We're not solving problem yet. Suppose somebody, well, there's one more thing I want to say. Just give me a minute. Let me draw another line. Then I'll tell you another. I think I talked about it in that thing we did, in the arithmetic we did. Let's say we'll have 0 here. Okay, we'll have, let's say 5 here. And here we'll have 9. And here we'll have minus 3. Here we'll have minus 10, okay? Now notice something. If I say x is greater than 5, so that means x starts here and then go that way. But 5 is not included. To show that 5 is not included, what they do, you draw a 0, but don't shade it, because 5 is not included. You see that, right? Okay, but suppose I then say that, I'll give you another example. Say that x is greater than or equal to 0. Okay, then when I say that, it means 0 is included. So I say it starts here and then it goes to the right. But you have to include 0, so you shade that completely, because 0 is included. Over here 5 is not included, so you leave a hole. Over here 0 is included, you close the hole. You make a circle around 0, but you close the hole showing that 0 is included. That's how you see this in books, right? That's how they draw that. Okay, so make sure you understand that, you see. So it's kind of elementary, but a lot of people don't know this, So, I mean, if you already know it, don't worry about it. But if you don't know it now, you know, see. So x greater than or equal to 0 means 0 is included. So it goes from 0 included, going that way, okay? That's all that means, 0 included. Okay, x greater than 0, greater than 5 is not included. So you draw a circle, but you don't shade it. So that's what that means. So given that, let's say somebody give you this 4 minus 4 is greater than minus 4 is greater than minus 10, okay, right? Or they can say let me see, they can say suppose they say x is less than or equal to 20, equal to, I keep forgetting to put to, equal to 20. You have to put that for it to make sense. Equal to 20, okay? So how do you translate that? Using the symbols. You remember the symbols? Less than, greater than, less than or equal to, greater than or equal to. So this one here, you translate it as this. Minus 4 is greater than minus 10. You see that, right? And then this one here, you translate it as x is less than or equal to 20. That's all that is saying, man. The mathematicians don't want to use the words. The words is too much. Because, the mathematicians love abstraction. It makes it easier to solve problems when you remove the words. That's why I'm telling you, words will kill you. Stay away from too many words. So mathematicians try to symbolize things. That way it's easier for them to visualize and conceptualize things, you see. So that's what that is all about. So I want you guys to understand that, because we're going to kick this off. We're going to solve a lot of problems in this area, okay? Okay, there's another thing I want to show you too before we continue. You're going to see this. Suppose I say, okay, let's go back here. Look over here. Look at 0. That's another thing there. I want to show you another concept there. You look at 0. What are the numbers to the left of 0 and the numbers to the right of 0? Immediately to the left of 0, you see minus 3, right? Immediately to the right of 0, you see 5, right? So another way to say that, you can say 0 is between minus 3 and 5. I'm looking at this diagram here. See, 0 is between minus 3 and 5. So how do you write that? Okay, let me write it again. 0 is between minus 3 and 5. You remember? 0 minus 3, 5. Okay, 0 is between that. How do you write that using this thing here? Using these 4 symbols. Any of the 4 symbols that will make it work. How do you do that? Well, you write it like this. 0, right? 0 is less than 5, and 0 is greater than minus 3. That's how you say that. You see that, right? 0 is between minus 3 and 5. You see how they sandwiched it? It's between there, right? 0 is between there, but minus 3 is on the left, because minus 3 is less than 5, and 5 is greater than minus 3, but 0 is between them. That's all that is saying, man. So you could have a situation, sometimes they can write, you can see this expression, using a symbol. X is less than or equal to 5, or X, is greater than or equal to minus 3. You can see that. In this case, we don't know what X is. We'll have to determine what X is. You see that, yeah? X less than or equal to 5. And then it says X greater than or equal to minus 3. To draw that, you're gonna draw it like this. So let's say X is here. Okay. And then if 5 is here and minus 3 is here. So the way you draw that, you're gonna say, so you're gonna put circle here and circle there, because minus 3 is included and 5 is included. Then you have to shade it like that. Basically, that's saying that X is between minus 3 and 5, and both minus 3 and 5 included. So you're gonna shade that like that, and then you're gonna say it's right here. Let me use a different ink. This is what they're talking about right here. You shade that like that because they're included. Minus 3 is included, 5 is included. You see that, right? Okay. Let me give you one more example. That way it helps you to understand. Suppose it says, they can say minus 3, X is greater, X is greater than minus 3, or X is, less than 5. How do you say that? How do you draw that? You go like that. Okay, X is somewhere here. Alright. And then 5 is somewhere here. Minus 3 is somewhere here. And then you draw the draw the circle. But you see, because in this case, minus 3 and 5 are not included. So you draw it like this. But he leave the circle not shaded, you see? Right there. You see that, right? So, but anyway, so that's, I want you to make sure you see this. It's very, very useful when when you're solving problems. You need to note that, you see. So, using X can be anything. X can be any number. It can be 0. It can be 1. It can be 5. But anyway, I wanted you to make sure you understand that before we move on, okay? All right, look at the, I introduced a bunch of diagrams. See the diagrams? I hope you can see it. You see the graph here, the graph on the top left side, this one here. Let me see, this one right here, okay? That one, let me do it a little bit better. This graph right here, this one right here, okay? You see that graph is, it represents y greater than or equal to minus 2x plus 8, okay? So notice that there is a line, and the line is solid, right? You see that the line is solid. The line is like a sloping downwards, okay? And then after that, then the graph is drawn. It's shaded on the right hand side. It's because the inequality says that y is greater or equal to minus 2x plus 8. I will explain all that as we go. And then look at the other graph, the one on the right, on the top right, this one here. Okay, look at that. That one says y less than 3x minus 7. Now I want you to notice how, you see there is a line and then a region is also drawn, right? Okay, notice that the line is dotted. It's not solid line. That's a reason why that is like that, because it says while less than. It doesn't include the line. Less than. It doesn't say less than or equal to. So if it includes the line, it will say less than or equal to. In that case, the line is solid. So all this will be clear as we go. But then look at the graph at the middle. See this one here? You see that graph contains both the one on the top left and the one on the top right. You see that graph contains both of them. You see where I put, you see the equations, and then you see the solid line, you see the other dotted line, and then the region here, depending on what you're solving, depending on what you're solving, the region here, the region shaded over here is the region that contains both of them, okay? Depending if you want to maximize something or minimize something, okay? All this stuff will be clear as we go, okay? And then look at this one over here. See, I listed the inequality symbols they use in mathematics. This one stands for greater than, okay? Greater than. And this one is greater than or equal to, okay? And then this one is less than, and then the next one is less than or equal to, okay? Now you see the other graph, the one right here, down left. You see how they draw three, somebody drew three, three linear equations, and then you see where they meet. That's where they call that, the place they write feasible region. Well, you see, you have to understand this thing we're doing here, linear inequality, very, very useful in solving a lot of problems in an organization. The organization can be private company, it can be government agency, it can even be the whole government, okay? You have state government and then federal government. You have agencies in those two sections of the public organization, okay? Then private organization like Apple or Microsoft, those are private organizations. So every organization uses the concept described by linear inequality. Sometimes, like this one here, let me see. When you see something like this, it's called linear programming. Okay, linear programming is a different course. It's a whole course by itself. It's an abstract course. We're gonna deal with that. I will deal with that later on in a class called finite mathematics. I will deal with some of it, and then eventually, if I have time, I will deal with linear. I will introduce you to linear programming. I'm not gonna go into abstract version of it. I will just do introductory version of it. Okay, so it's very, very helpful. You see that thing you see here, this thing you see here, very, very helpful in solving what they call resource allocation problem in any organization, whether private or public, right? So linear programming, it's like a type of linear programming. It's used by companies, governments or public governments or private agencies, right? It helps them to plan and decide how to allocate resources, right? I don't care what organization you are in. The managers there, the people that run the organization, their main problem is always how to allocate the resources, because resources are scarce. In economics, they tell you resources are scarce. Because of scarcity, then we'll have to make choices. And then when you make choices, you gotta let some stuff go. You gotta include some stuff. So this is resource allocation. It happens everywhere. Okay, this is the job of the person running that particular organization, whether private or public. Their job is mainly how to allocate resources. Resources can be money, people, time, machines, stuff like that, labor. Those are resources. So their main job is to effectively and efficiently allocate the resources. That way the company can make money. Or if it's a public organization, that way they use the taxpayers' money wisely. Okay, so this is what, you know, if you understand how to solve linear inequalities, you closer to understanding linear programming. Okay, because it's the same thing. The idea of linear programming comes from solving a bunch of linear inequalities problems. Okay, well, yeah, solving a bunch of inequalities. You know, see, you have linear equations and then you have linear inequalities. Okay, linear inequalities can be in one variable or two variables. The one I showed you here is in x and y. You know, this one is in x and y. But what we're gonna deal with in this video is linear inequalities in one variable. See right there, in one variable. Okay. Okay, see the feasibility region here. What they mean by feasibility, they're trying to solve some problem. So they want to find out what is feasible, what is allowable. So that's how they draw this bunch and then find the region. You know, like I said, we'll deal with that a little later. So I wanted to explain these graphs here, and then and I also want you to understand what they mean by that: greater than or equal to, less than or equal to. You know, we're gonna understand that as I go on. Okay. All right. So let me start by explaining what they mean by an inequality, and then what they mean by a linear inequality in one variable. All right. Basically, an inequality relates, right? It relates algebraic expressions using such symbols as these symbols here: less than, okay, less than, greater than, okay, or less than or equal to. Okay, and then this one is greater than, or equal to. Okay, so basically an inequality takes two expressions. I would say two algebraic expressions, and try to compare them. That's all that is saying. It compares them using either less than, or using greater than, or using less than or equal to, or using greater than or equal to. That's all that is saying. And then the other thing I want to introduce you to is the concept of, you remember we talked about linear equations. They also talk about linear inequalities, a linear inequality in one variable. What does that mean? Okay, it just means that it means that it's an inequality. Okay, it's an inequality. An inequality that can be written like this, written in this form, in this form. Okay, in this form, it can be written like this: a times x plus b is less than 0. It just can be written using any of those symbols. Or it can be written like a times x plus b is less than or equal to 0. Right? Or it can be written like this: a times x plus b, okay, is greater than 0. Or it can be written like this: a times x plus b greater or equal to 0. So you can use any of those symbols because it's in one variable. One variable here, one variable they're talking about here, one variable here is x. Okay, x is the variable. And notice that a, right, a and b are real numbers. Okay, real numbers, and the a cannot be equal to 0, because if a is equal to 0, then it eliminates the x. Okay, so that's all they're saying there, man. A linear inequality is just a linear inequality in one variable is an inequality that can be written. Yes, it sees that word, an inequality. What is an inequality? Again, we defined it here. An inequality, right, is an expression using these symbols. So a linear inequality in one variable, right, is any of these, man. It can be any one of these. That's all. Okay? That's all that is saying. But I want to go a little deeper because I know some of you understand this because you did a lot of, you have been exposed to this. I want to go a little deeper. I'm going to explain inequality. Go a little deeper. That way I'll make sure everybody knows what I'm talking about, okay? When I explain it, they should be able to understand it, you see. So, alright, so I'm going to use what they call the concept of order. The concept of order, or you can say ordering, okay? Ordering the numbers. To go a little deeper, okay? Basically, it involves comparing numbers, okay? Now, recall that we talked about the Cartesian coordinate. Everything boils down to Cartesian x, y, and this is 0 here. You can have 1 here, you can have 2 here, minus 1, minus 2, 1, 2, minus 1, minus 2, okay? You remember that, right? But you see, this thing is reproduced on that thing. So, but what I'm going to do, I'm going to use I'm just going to use the x, okay, to explain this. Now, watch this. Suppose you have this is the x section of the Cartesian coordinate. You have 0 here. Let's say you have, let's say we'll have 2 here, and we'll have 7 here, okay? Let's say we'll have minus 3 here, and we'll have minus 10 here. I'm just choosing any numbers are random, okay? Now, the concept of order, right, in mathematical sense, how you order things are, put things in order. It's about, well, they call it order. It can be called also order relationship. Order relationship between numbers, okay? Order relationships between numbers. Now, notice that any number on this line here, any number on the x-axis, right? Any number on the x-axis is greater than the number to the left of it, right? If you keep going from left to right, even if you go from right to left, any number on the right is greater than any number on the left. That's basically the concept of order there. So you see that 7 is greater than 2, right? 7 is greater than 2. 2 is greater than 0. 0 is greater than negative 3. Negative 3 is greater than negative 10. Okay? I mean, 7 is greater than negative 10. You see that? This is the concept of order relationship, right? You see that? How do you write that? Then this is how you write that using those four ordering symbols. You remember our ordering symbols? Less than, greater than, less than or equal to, or what is that? Greater than or equal to. So you can say 7, right? 7 is greater than 0. You see that, right? The other way you can write that, you can write 0 is less than 7. You see the same thing. Those mean the same thing, right? So you can say minus 10 is less than minus 3. You see, right? Because 3 is to the right of minus 10. Alright, that's what I want you to see. That's where this stuff, where they start using this stuff. I mean, this example should help you to understand what those 4 things mean. Alright? Okay, so 0 is less than 2 because 2 is to the right of 0. You see that, right? Yeah, it sounds elementary, but it's important. You see why in a minute it's important. Okay, you can say 2 is less than or equal to 2. Do you see that? Make sure you understand that 2, you can write it like that. 2 is less than or equal to 2. Well, it's not less than, but it's equal to. That's how you can write it. You see, one of them is true. Either it's less than or equal to, which it means the second one is true. It's equal to. 2 is not less than 2. 2 is less than or equal to 2. Make sure you understand that. Okay? So these are the stuff I want to make sure I have you to understand. Now, suppose now, instead of using numbers, we use variable. We could say x is less than 7. What does that mean? What does it mean to say x is less than 7? Draw the number. Okay, draw the number lines. This is x. This is the horizontal line representing x axis. Okay, 0 is there. We know 7 is somewhere here. And then when you say x is a variable. We don't know. X stands for any real number. When you say x is less than 7, it means you start here. You start at 7, you go that way. Anything. X could be 2,000. Right? X could be 2,000 somewhere there. X could be 200. X could be 20. But x is less than 7. We don't know exactly what x is. Just says x is less than. It goes that way to infinity. Okay? Now, another thing you need to know there, when they say x, when they say x is less than 7, it doesn't say x is 7. X is not 7. But suppose I write, keep your eye on this. Suppose I write x is less than or equal to 7. It's saying the same thing, but this time it's 7 is included. So how do you differentiate between those two? Well, x is less than 7. When you draw it, like this. 7 over here. And then you can draw 0 here. Then you can, the way they do it, you can just draw it like that. Going that way is that. X less than 7. It can be any number to the left of 7, okay? Now, when you say x is less than or equal to 7, how do you draw that? Well, you draw the line like that, put 7 here, okay, then you draw the circle. Okay, you see over here there is a hole. The first one, x less than, there is a hole. Now, when you say less than or equal to, then you close the hole because 7 is included. That's how you represent that. And then you go that way. You see that, right? It goes that way. It can be anything. It can be 2,000. It can be 200. It can go to infinity. But 7 is included. 7 is included. So you shade it like that to show 7 is included. But on this less than, there's a hole there. 7 is not included. That's how you represent that. 7 is not included. 7 is included. We talked about this before. When we did arithmetic. So I want you to make sure you understand this, okay? Now, supposing we say, remember this now. Look at this carefully. Remember that drawing there. See, 0 is right here, right? 2 is here. 3 is here. 7 is here. Now, notice 0. What is immediately to the left of 0 is minus 3. What is immediately to the right of 0? What I wrote down is 2, right? Now, supposing somebody say between minus 3 and 2, how do you represent that? 0 is between minus 3 and 2. How do you represent that using any of our 4 symbols right here? Using any of those symbols. Remember what let me draw it again. 0 2 minus 3. 0 is between minus 3 and 2. How do you represent that? Here's how you represent it. You say 0 is less than 2, or 0 is greater than minus 3. That's how you represent that. You see that, right? Okay, but instead of 0, we could use x. We could draw something like this. Say x here. We'll say 7 here. We'll say minus 10 here. Okay, and then we'll say x. X is between, it's called between, right? X is between 7 and minus 10. I'm sorry. X is between 7 and minus 10, like that. That's how you write that. X greater than 10, x less than 7. You see that, right? So, but if you want to include minus 10 and 7, then you write it like this. X, well, let me first draw it for you. Then you draw the thing there. Okay, then you put x here, you put 7 here, you put minus 10 here. But this time, well, it's over here. This is actually how you draw the first one here. You put a circle with a hole in it. But on this case, you put the circle, but you gotta shade it. You have to shade it up like that. And then this is what you draw right there. Let me use a different. So this is how you represent that, you see. Alright, that's how you represent that. You see that, right? And then you write it like this. X is less than or equal to 7. X is greater than or equal to minus 10. See, that's how you write that. That's how you represent that diagram there. You see that, right? And this is how, this one here, that's how you represent it right there. Because there's a hole right there. There's a hole, it's not shaded. And then this is the distance, okay, between them. X is between them. There may be occasion, let me show you. There may be occasion, I put it on the left here. You could have a situation where you have x, okay, let's say this is 7, and then you say x is less than 7. That's a hole here, and then x goes like that. It's less than. It keeps going, right? In that case, you represent it as even though, well, you don't have to put x there, but x goes like that, starts here and goes like that. In that case, you say x is less than 7. That's how you represent that. But you can also have a situation where you say like that. This is a 7 here, and you 7 is included, okay, and then x is here. X goes like that. Then in this case, if 7 is included, you write it x is less than or equal to 7. But 7 is going to infinity. But it's less than 7 or equal to 7. But you're going to the left of 7. Okay, you can have the same thing the other way. Right? You can say, you put a number here, call it, you can call it negative 2. Okay, then you say x, this is x is greater than negative 2. In that case, there is a hole here, and then you say x is greater than negative 2. But you see, when you draw that, you put a hole here, then you go like that. X keep going to infinity to the right of negative 2. You can also have a situation, let's say negative 2, you go like that, x going to that direction, right? But 2 is included. If 2 is included, then you draw it like this. You close the hole. You close the hole. This is x. You say x, right, is greater or equal to 2. But x will keep going that way to infinity. But 2 is included. So there is no hole here. but in this case they say, oh, 2 is not included. In this case over here, 2 is included. So that's how you write that. You see that, right? But anyway, so I want you to get this. That's where all this stuff came from the Cartesian coordinate system. Every number, you have a number, any number to the right of that number is greater than non-number. Any number to the left of that number is less than that number. If the number is included, then you say, well, it's less than or equal to that number. That's all that is saying. If you understand that, the rest of the stuff will be easy for you to understand, okay? Alright, folks, so there are properties of order. There are properties of order that you need to know. That way, when we start solving problem, you're not going to be confused. So I need to mention these properties before we start solving problem, okay? Well, of course, when you're dealing with inequalities, you can add, subtract, you can multiply, divide, so all those 4 operations are involved, when you're dealing with inequalities. So let's start. We're gonna have properties of those operations. But before I do the properties of those operations, let me introduce 2 concepts. The concepts of comparison, which you already know about, and the concept of what they call transitivity. Okay, so let's do the property. Well, let's do it this way. We'll call it comparison property. Okay, comparison property of order. Okay, you can call it order or ordering. Okay, so basically what that is saying is, what this comparison property is saying is, if you are given, let's say you are given any 2 real numbers, okay, any 2 real numbers, any 2 real numbers, A and B, okay, you're given that. Okay, then he says only one of the following, the 3 statements, okay, only one of the following 3 statements is true. Okay, 3 statements. The 3 statements are: 1, A is less than B. Okay, or 2, A is equals to B. Or 3, okay, A is greater than B. Okay, one of them has to be true. 2 of them cannot be true. 3, all of them cannot be true. One of them must be true. This property, well, you see what he's saying. What is the property saying? Basically, what he's saying is, let's say you have a x-axis, right? And you have A here. Okay. What he's saying, what the number 1 is saying is either B is over here. B can be over here. In that case, B is greater than, that's what he's saying there. B is greater than A, or A is less than B. Okay, in the second case, what he's saying is, if A is here, B can be here too. So they can be equal. They can coincide. So A is equals to B. In this case, A is less than B. Or another alternative, if A is here, okay, and then B could be here. B could be on that side, on the left of A. In this case, A is greater than B. You see that, right? B is less than A. That's all that is saying. This is, well, I don't want to say more. That's all that is said. Given any two numbers, they are real numbers. One of the following can be true. Two of them cannot be true, and three of them cannot be true. Only one of them can be true. So that's that one. Okay. So the second property of the ordering of numbers, right? The second property I want to discuss is called the transitive. Property, okay? Transitive property of ordering. Okay, what that is saying is, okay, if you are given for all real numbers, these are all real numbers, okay, real numbers A, B, C. You're given three real numbers, right? Okay, it says if A is less than B, right, and C, and let me see, and B is less than C, then by definition, right, A must be less than C. Well, let me help you understand that. Let's say you have this is x-axis here, all right, x-axis, and what they're saying, look at that condition given there. This is A. If A is less than B, B is over here. That's all that is saying. If A is here, then B is over here, because A is less than B, right? And then if they say it's also B is less than C, C is over here. You see that, right? That's all they're saying. A is less than B, B is less than C. Basically, C is to the right of B, B is to the right of A. That's all they're saying. If that's the case, then A is less than C. You can see it. A is to the left of C. That's all that is saying. If these conditions hold, then see, you can see it from there. A is less than C. That's all that is saying, man. You can use real numbers, the numbers. You can use number to demonstrate that, but you can see it from the Cartesian line, right? Okay, so we're done with that. Let's go to algebraic properties of ordering. So number three is let's do addition. Let's say addition. We can join it with subtraction, because they're saying the same. Subtraction property of ordering, okay, of order. So basically what this is saying, you probably have a clue from the two things we discussed above. If given these three I'm going too fast. Given three real numbers, okay, real numbers A, B, C, okay, right? If you have three real numbers like that, and then it says if A is less than B, then A plus C is less than B plus C. That's all he's saying. If A is less than B, let's say right here, A, and this is B. A is less than B, okay, and then you have C somewhere. If you add C to A, if you add C to A, right? You add C to A, right? And then you have to add C to B. Like this is one we're solving problem. They will still be less because A is still to the left of B. That's all that is saying. If A is to the left of B and you add C to both of them, A will still be to the left. The result will still be to the left, right? This will still be to the left of that. That's all that is saying. The same thing with subtraction. If A is less than B, right, then if you subtract A, you subtract C, right, it will still be less than B, subtract C. That's all that is saying. You subtract here, instead of addition you subtract C, it will still be the same. That's all that is saying, man. So you get that, right? So if A is less than B, no matter what if you add or subtract something, and then you add or subtract something from the other side, it will be the same. That's all that is saying. Okay? And then number three property, number four property, okay, it's called, let me see, what is it called? It's about multiplication property, okay? Multiplication property of order, okay? Of order. By extension, multiplication goes with division. Division property of order, okay? Because those go together. Now, this one is also very intuitive. I will explain it to you. Given three real numbers, okay? Real numbers. A, B, and C, okay? Right? You're given these three real numbers, right? As long as C is greater than 0, that C is positive. That's what that means. C is positive. C is, hang on, I want to make sure you get that. When they say C is greater than 0, all they're saying is C is positive. That means C is positive. That's all they're saying. Because you see in the number line, if C is greater than 0, then C is over here. Not on the left. C is greater than 0, right? Given that condition, right? Then if A is less than B, then A times C is less than B times C. You can see that. Okay, if A is here and B is here, because A is less than B. If you multiply that with a positive number, multiply that with C, C is positive, you multiply that, it will maintain what they're saying, it will maintain the order. It's not going to change the order. Alright, the same thing with division. Okay, if A is less than B, then as long as C is positive, then A divided by C is less than B divided by C. You see that, right? As long as C is positive, okay? But here is where something happens. C will give you that condition there. Remember that condition there? Suppose we'll modify that condition. Suppose now we'll say you say given three real numbers, right? Real numbers, okay? A, B, and C. But C, well, let me be consistent. C is less than 0. Okay, that means C is negative. You understand that, right? C is negative. What does it mean to be less than 0? 0 is over here. It means C is over here, to the left of 0. You see that, right? This is X. So it means C is to the left of 0, okay? C is negative. That's all that means. Make sure you understand that. When they say C is less than 0, it means C is negative. That's all. To the left of 0. That's all that means. If that's the case, all real numbers, the C is negative, right? But then when you multiply, if A is less than B, right? Then when you multiply with a negative number, negative C, it will be A times C will be greater. You see, look at that. The other one is it maintains the other. A times C will be greater than B times C. You see what is going on? It reverses the other. It reverses the direction of the. You can call it the order or the direction of the inequality. You will reverse it when it's negative. The same thing with division. If A is less than B and C is negative, right? Then C is negative. A divided by C will be greater than B divided by C, as long as C is negative. The division is the same thing as multiplication, because when you divide, division is a shorthand for multiplication, right? So make sure you understand that it will reverse the direction of the inequality or the order of the inequality. I'll give you an example. Okay, if you have an example, is important here. Example is important under this number 4. Let's say you have, we'll give you an example now. Let's say you have 0 here and you have 4 here. Sorry. You have 4 here, okay? You have 4 here and you have -2 here. Now pay attention now. Okay? All right. Okay, let's introduce one more. Let's say this is 3 here. Okay, so this is A and this is B. Notice that 3 is less than 4. That's B. A is less than B, like they said here. Like they say here, right? A is less than B. Okay, because 3 is less than 4. But now let's say this is C. C is negative, right? Well, let's do positive first. Let's do positive first. Sorry. We'll do positive first. That way you can. Well, we'll do it together. Let's say we'll have 6 here. It could be 1, but I tell you what, I don't want to confuse you. We'll do one by one. Let's put C here. Okay. Then you see, if 3 is less than 4, you see that, right? But now when you multiply both sides with 6, what do you get? You say 3 times 6 is less than 3 times, what is that? I'm sorry, 4. 4 times 6. We'll see, we'll check out. What is 3 times 6 is 18. See, it's less than, when you say 4 times 6, what is that? 24. You see? You can see that it holds true, right? When 6 is positive. Okay. If you want, we can use 6. It doesn't hurt to use. We use 6. Let's say 6 is negative now. We have negative 6 over here. And then what happens? What happens here? What happens? You have a 3 times negative 6. Okay. See, you see the sign here, and then 4 times negative 6. What does it come out to? What is 3? What is 3 times negative? It's negative 18. Over here is negative what? 24. But you see, if you draw the line, 24, negative 24 is here, and negative 18 is here. So negative 18 is larger than negative 24. So you have to reverse the inequality. You can't leave it as less than. You gotta be greater than. You see that, right? That's all that thing is saying. If you multiply by negative, you have to reverse this. You reverse the order or the ordering. You revise the direction of the inequality. That's all that is saying. The same thing with division. Let me give you an example with division, right? It happens with division like this one here. And okay, we can do division too. Let's do division if you have 3 less than 4, right? Okay, so suppose you divide with positive 6. What happens? You say 3 over 6, right? Less than 4 over 6. You see that, right? If you divide that out, you will see it is true. Okay, we're gonna put it in decimal. That way you can see it. See, we'll put it in decimal. 3 divided by 6. 3 divided by 6. What do you get? You get 0.5. Okay, it's less than. What is 4 divided by 6? 4 divided by 6. You get 0.66, which is something as 0.67. You see? So this is still greater than that. It's actually 666 or 6. You can also say 0.7. You see, it's greater than that. You can see that, right? Okay. But suppose we use negative 6. You have 3 less than 4, and then you divide it by negative 6. Divide that by negative 6. What do you get? You see that, right? So automatically you're gonna get the same numbers. It will be negative 0.5, right? And then you're gonna get negative 0.7. Which one is greater? If you draw it, negative negative 0.7 will be here, and negative 0.05 will be here. I'm sorry, negative 0.5 will be over here. You see that negative 0.7 will be on the left of negative 0.5. That's all that is saying. And you know negative 0.5 is greater than negative 0.7. You see that, right? That's all that is saying, man. So keep that in mind. Keep this in mind when we work with problems. When this is negative and when it's positive. It's positive here. So that will help you when we solve problems, you see. Okay, folks. We're going to solve a bunch of problems in a minute, but I want to summarize what we just did above, okay? Just you can read this, make sure you understand it. Adding to or subtracting from each side of an inequality, right? The same number. Adding to or subtracting the same number from each side of an inequality preserves, right, the direction of the inequality. It changes nothing, okay? It changes nothing when you add or subtract the same number, okay? And then 2, multiplying or dividing each side of an inequality, right, by the same positive number. You gotta pay attention there. The same positive number, okay, preserves the direction of the inequality. In other words, it changes nothing. You multiply or divide each side of an inequality by the same positive number. As long as the key is positive. If it's positive number, it changes nothing, okay? It stays the same. Now, here is the one that you gotta pay attention to. You can just remember this and forget the other one. This is the only thing that changes something. Multiplying or dividing each side of an inequality by the same negative number reverses the direction of the inequality. In other words, if you multiply both sides of inequality by using a negative number, right? If you do that using a negative number, then it changes. You gotta reverse the direction the inequality sign is facing. If it's saying less than, then you gotta change it to greater than. That's all. So if you can just remember this is the number 3 is where things are changed. Things changes when you multiply with a negative number. Multiply or divide with a negative number, okay? Don't forget that. Multiply or divide with a negative number. Then things change. So let's go to a bunch of problems, man. Okay, here's example 1. By the way, in each you solve, and then 2 represent each, okay, using using interval notation, okay, interval notation. That's what we want. That way you see how it's done, okay. First you solve, then you represent with interval notation. I have a bunch of them. Okay, so what do you do there? How do you solve that one? How do you proceed? Remember the rule, man. The only time something changes is when you multiply or divide by negative number, okay? Alright, so what is that? What do we do with that, man? Remember, we're trying to solve for x, okay? In this case, we'll solve for x. So we'll do a trick. Well, it's not a trick. We divide both sides by 5, okay? It will be 5 over 5. Initially, I'm gonna show you, what I'm doing. Then I'm gonna go fast, okay? 35 over 5, okay? You see that, right? Divide, because you want to get rid of, you want to put x by itself, okay? It's less than equal to, see, that one is less than equal to. Then you have x less than equal to, what is that on the right hand side? If you divide by 5, you get 7. So we're done. We just have to represent it. How do you represent that? See, that's why I took my time. If this is 0 here and this is 7 here, what is 7? X less than or equal to 7. Then you draw the thing here, and then you draw the thing here, and then it's going that direction. It includes 7, so you shade the whole thing. You shade the whole damn thing, okay? Sorry, man. You shade the whole thing to show it 7 is included. Okay, so I'm not a good drawer, you see? So you shade it like that, no hole. Somebody looks at it, there is no hole, you see. Actually, if you use it, actually, this is the drawing. Actually, sorry, this is the drawing. You draw it. I made a mistake. You draw it and then you throw it. You gotta represent it. Draw it. Draw it using a Cartesian line. Using Cartesian line, okay? Cartesian line, and then you represent using so to use interval notation here is basically says that because you see x start from 7 including 7 and go that way. So use interval notation, remember it goes to infinity, it doesn't stop anywhere. You said then negative infinity, right? Let me see, yeah, negative infinity. It goes all the way to negative infinity plus 7. And 7 is, since 7 is included, right? So since 7 is included, what they do, you go like that. I think we talked about that. To show that 7 is included. Right? Yeah, to show that 7 is included, you do like that. That's all. That's all you gotta do, okay? There's no magic to it. Okay, I covered this before, but if I didn't cover it, let me explain it now. When you have there are 4. Remember, we got 4 inequality. We're done with that problem, but I want to explain something to you. You have less than, and then you have less than or equal to. You have greater than, and then you have greater than or equal to. This one let's use this each time. Oh, we know what? Let me show you each time, and that way when I do it, you're not confused, okay? So if you know what? Let's do it. I want to do it a little better. That way you can see it. Greater than, right? And then greater or equal to. Let's clean this out. So if you say x less than, less than a. We use a general number. Number a is a real number, okay? If you say x less than a, right? what that means is A is not included, so it will be A here and then to infinity, because it's going the negative, that is going to the other direction, because this is going like this. A is here and then it's going that way. You see, A not included. And but then when, if on this here, if we say A less than or equal to X, right? In this case, it's like this. It start at A here, but A is included, right? And then it keeps going, but A is included, okay? So in that case, it goes negative infinity and then A included right there. You see it, right? Okay, but in this case here, if it's X is greater than A right here. Okay, so A is here. I'm sorry, I gotta give you more space. That way you can see it. In this case, let's say A is here, is going this direction. A not included, okay? A is not included. So in that case, you have A going to positive infinity, A not included. Now, when it says X greater than A right here, here A is included. So you start with A, you're going that over there. Here A is included, so you gotta do like that. So this is, I'm sorry, this is, I hope you see what I'm doing. This is A is included. That's how you write A is included, going to infinity. You see that, right? You never say, see, when you have infinity, you never include infinity, because infinity doesn't end. You never write anything like that, okay? Or anything, you never close infinity with that, because infinity keeps going. And you never write anything like this. Never. You never see anything like that, infinity somewhere. Never. Because it's always the open interval like that. It's called open interval. Alright, so I used that in example number 1 to show you a couple of things. So let's keep going. Look at example 2. Example 2 says solve for that. 6x greater than equal to minus 24. Okay, so how do you handle that? What you do, you get rid of 6 on the left. You say 6 divided by 6 is greater than whatever you do on the left, you do on the right. Minus 24 over 6. Okay, and then x is greater. You see that, right? X is greater or equal to, if you divide, you get by 6, you get 4, negative 4. Okay, so to draw that, and represent that, you represent that like this. This is let's say this is negative 4 here. Okay, you do that, is greater, it goes that way. Okay, and 4 is included. Okay, so since 4 is included, you shade that thing, you shade it, no holes, and it goes that way, keep going to infinity. Okay, so how do you represent that? You represent it like this in interval notation. Let me see. You represent it as minus 4. Sorry. Oh my God, I'm too much hurry. Minus 4 is included, okay, and then infinity, because it keeps going. You never say like that. You never do like that, never, because then you cut it off. Infinity doesn't end anywhere. Okay, so we're done with that. You see that, right? Make sure you're understanding that, man. So we keep going, because we got a lot of stuff. I don't want the video to be too large, so, but we got a bunch of problems to solve, you see, so I have to keep rushing. I hope I don't make mistake while rushing, you see. So, but anyway, you have minus 7x greater than 49. What do? You get rid of 7 on the left side, because basically to get rid of negative 7 on the left, you have to divide by. I hope you see that. Now let's do the other one. Now I gotta be a little bit careful, that way I don't make a mistake, break my own rules, you see. So what is that there? X, that is x what? Okay, you see that there says negative x less than 0. Now you just proceed carefully. It's not difficult. You gotta pay attention to what you're doing. Now, to put x by itself, remember we isolate x. To isolate x, you gotta divide by -1. When you divide by what will happen? The sign changes. The order, whatever you call it, order or direction of the inequality changes. So you divide negative x divide by -1. You change the sign. Alright, of course you divide that by 0, it stays 0. So see, that cancels the negative sign out, because you see it's like here they have -1. So that becomes x greater than 0. That's all. That's all, man. So you draw that. So x greater than, where is 0? 0 is right here, and then 0 is not included. So it goes like this. 0, you circle it, it goes that way. So that means let me see, 0. See, that's a good example. When something is greater than 0, then it goes to infinity. See, you see that, right? So actually I like that example. When something is greater than 0, it means it's on the positive side of 0. That's all that means, man. Okay, so let's go to the other one. What is this one here? This one is number 5. So it says you have 7 minus 7/8 times y, right? And then the other side is -14. So how do you proceed there? Okay, so basically what we're gonna try to do, right? We're gonna have to get y by itself on the left side. How do we do that? Well, we can proceed in different ways. First, let's multiply both sides by +8, right? Because you don't want to make it more complicated than it is. We're gonna get rid of 8 first using +8. So we multiply by +8 minus 7/8, right? Y. And then we'll multiply the other side by +8. Whatever you do on the left, you do on the right. So what do you get there? You gotta be very, very careful, man. Okay, so that's what you get. So you don't want to do too many things at the same time and then get confused. That's what you get. -7 times y is less than -112. Now you divide with -7 to get rid of -7, right? And that's where the order changes. So let me go ahead and do it. -7y, order changes, then -112 divided by -7. You see that, right? Okay, you see that. That's what is going on there. If you do that, what do you get? You get y, because this cancel out, is greater than, and remember, negative divided by negative is positive. You get +16. That's all, man. That's all. So you gotta be careful. You don't want to mess up, so you just be careful when you're doing all this stuff, So, and then we can represent it, the solution. If you have 16 here, right, it's saying y greater than 16. By the way, y and x, it doesn't matter. You can use any variable. You can use t, you can use w. It's just a variable that represents a real number in the problem. So you have 16. 16 is not included. You draw that. 16 not included, and it goes that direction to infinity. So that means 16 to infinity, like that. 16 not included, okay? So we're done with that problem. You see it, right? Okay. See, all this stuff we're doing. See that stuff we're doing when we get to calculus. If you understand the calculus, it will help you a lot when we do calculus, okay? So let's move on. The next one is that one there. Now you're dealing with fractions. So what? We're not scared of fractions. Remember one time we fought with fractions. Okay, this time, what we're gonna do, we're gonna, see they're using T there. T, it can't be anything. It can't be W, it can't be N, it can't be C, but they're using T as the variable. So we'll divide the left side. To get T by itself, we'll divide the left side by negative 0.03. That's all. That's how we get rid of that. Right? And then we'll change the sign of the inequality. So basically that's negative 0.03 T divided by negative 0.03. We change the sign, less than or equal to 0.12, right, over negative 0.03, because that's what we did over here. And then T will be by itself, less than or equal to, what is that? So you gotta divide that. You can either do fraction, or not. I mean, there are many ways I can change it into fraction, but we can just leave it in decimal notation where they have it like that. All right, it's up to you what you want to do. You see, so if you go ahead and divide that, what do you get? You see, 0.12 divide 0.03. Actually, it becomes a negative number. You see, negative divide negative is positive, so it becomes 4. You see that, right? You can try that with your calculator, see? So how do we draw that? Okay, you start from 4. It says T is less than or equal to 4. 4 is included, okay? This time 4 is included. And then it says less than. T is less than, okay? So 4 is included, you shed everything right there. 4 is included there, and it's less than 4. Less than or equal to 4. You shed everything, and then you go this direction. That's all. So how do you represent that with so 4 is included right there like that, and then negative, it goes to the negative infinity direction. That's all. That's how you say it there. It's no more than that, man. So don't overthink it. The problem is solved, so we'll move on. I think I'm done. I want to start with this, and then we'll go to application, or maybe I can do more of this. All right, folks, I just realized that I didn't quite finish example number 3. As I was going through the video, I realized. So I forgot to draw. Let's draw it. Let's just draw it, and then we'll move on. So if 0 is here, negative 7 is there. All that is saying is x less than negative 7. Okay, so x starts here. 7 is not included. Okay, so it starts here, and then it goes that direction. So it will be negative infinity and 7. 7 is not included, okay? That's all that is saying, man. So sorry about that. Let's move on to the next problem. So let's move on to number 7. Notice that it's a little bit, as we go, it gets a little harder and harder, but it's not too hard. It's just a little complexity. Okay, you see what is given there? You are given 8x plus 9 is less than equal to minus 15. It's not hard. It's the same thing. They just added a little dimension to it. All right. So what do we do there? We'll start doing what we've been doing. It's the same thing. Same thing we've been doing. We'll keep doing it. Okay. All right. So it's just like linear equation. We're trying to isolate x on the left. So we'll move things around. And remember, the only time you change the sign is if you divide or multiply by negative. Okay? So that's 8x less than or equal to minus 15 minus, we'll move 9 over, minus 9, okay? 8x less than equals to, you add that up, what do you get? You get minus 24. Okay. All right. So you keep moving on. You keep moving on. Okay. So to get rid of 8 that you use to multiply x, you divide by 8, and it's positive, so nothing changes. X less than equals to minus 24 divided by positive 8. You see, nothing changes, man. So it's x less than equals to negative what is that? Negative 3. Okay, so I don't want to forget it. You gotta draw, and then you gotta represent. Right there, you draw it. See, from the drawing, then you get the interval. So always keep in mind. Let me show you. If you have 0, well, you have x and y, right? Okay. From 0 over here is positive infinity. Over here going to negative infinity. That's all. Just remember that, man. Remember that, then everything will be easier for you. Okay, so we have negative 3. Let's say negative 3 here, and then it's included. It's draw that. It's going this direction here. Okay, and then 3 is included. So you shade that solid. There's no hole there. Okay. There's no hole. You plug in the hole. So that the same thing, you represent it like the, I'm sorry. You never include the infinity, man. If infinity doesn't get into anything, you just, because infinity doesn't stop, it keeps going. So you can't constrain it. It's negative infinity, and then minus 3 is included right there. That's how you draw that right there, okay? So we'll move on to the next thing. Let me see this one here. It's almost the same thing, just the sign changed. So what we'll do there, we'll isolate stuff on the left side. That's all you gotta do. Isolate. Okay. Isolate stuff on the left side. You say 5y greater equal to 3y 3y minus, I just realized 9 minus 1, because when you move 1 over it becomes negative, and then you gotta move 3 over to left side, because 5y minus 3y is equal, is not equal to, greater than equal to minus 9 minus 1. You see that, right? So you simplify both sides. You get 2y greater than equal to minus 10. You divide both sides by positive 2. You get y greater equal to negative 10 divided by 2. Okay? So you get y greater equal to negative 5. That's it. You see that, right? So you gotta, do it systematically. That way you don't make mistake. So that's how you do that. Okay? So we draw this thing. Yeah, we'll have to draw this thing. We'll draw it, and then we're done. How do you draw that? Okay. If after you draw it from there, then you can get the interval notation, because interval notation and the drawing, they're saying the same thing. So here you got negative 5 is included. Okay, so when you draw the circle here, negative 5 is included, so there is no hole. You cover the whole thing. Cover the whole thing up, no hole there. Sorry about that, not to the other direction. It doesn't go that way. Because it says positive, I'll show you, just give me a minute. It says greater than, y is greater than or equal to 5, so it goes on the other direction. All right, so once you do that, what do you get? What you do here is it says right here 5 is included, negative 5 is included, and then it goes in the positive direction of the infinity. Okay, it's like that. All right, you see that, right? So basically we're done with that. Okay, here is number 9 of our problems. Number 9 says 6x plus 7 less than or equal to negative 17, right? Alright, so we'll knock that out quick. So always keep in mind we'll solve, and then we'll graph it, and then we'll put it in interval notation, okay? So those are the 3 things we're gonna do. That's why I wrote that up there. So we'll solve. We'll begin to isolate x on the left side. We'll have 6x less than or equals to minus 17 minus 7, okay? Alright. We'll simplify the right hand side. We'll have 6x less than equals to minus what is that, 24, okay? Right? Alright, so, and then we'll say x less than equals to negative 24 divided by 6. You see that, right? But anyway, so that's what is going on there. And then after you do the division, you will get x less than equals to minus 4, and then we're done. That's what you get there. And then you gotta draw. Well, we're not quite done. You gotta draw. We're done with solving. We'll draw it. Negative 4 is over here, and then it's included. So if we draw that, it's less than equal to 4. So it's gonna go that direction to infinity, and no hole left, okay? You can't leave any hole there because 4 is included. So no hole, and then the interval is negative 4 included, alright, negative 4 included to negative infinity, okay, because it's going to the left side. Alright, so that's what we'll have there. Let's kick it out. Number 10 says negative 5 times x is minus 4 less than 6, okay? So we kick that out. What do we do there? We do like we normally do. We isolate x on the left. Alright, negative 5x, alright, is less than 6 plus 4. We'll move for the other side, it becomes plus, okay? And then we'll simplify negative 5x less than 10, okay? Now we'll have to divide by negative 5, so that will change the sign, okay? Negative 5x divided by negative 5. That will change the sign, okay? So I was gonna write the other one. You change the sign to this, and then it says 10 divided by negative 5. That changes the sign, okay? And then you have x greater than negative 2. You see that, right? So that's what is going on there. Okay, so then you draw the thing, you draw it. Negative 2 is here. X is greater than it. 2 is not included, so it goes that direction. X greater than 2. You see that, right? So 2 is not included. There's a hole there. We'll leave that hole there, and then we'll say you start from negative 2 and you go to infinity to the right, in the other side, the right direction, okay? That's how you represent that. And we're done with that. We'll go to number 11. Number 11 says 6x plus 3. Alright? 6x plus 3 is less than 3x plus 12, right? So again, we'll isolate the variable on the left. We'll have 6x. We'll move the other one around, negative 3x less than 12 negative 3. You see it, right? We didn't multiply with negative numbers, so we'll preserve that. So you see that, and then we'll have we'll simplify. What do we have? We'll have 3x less than 9. You see that, right? And then x, we divide by 3. We're not changing nothing because it's positive number. And then x is less than 9 divided by 3 is 3. You see that, right? So we didn't change anything. Okay, we did not change anything. So we'll have to draw the graph like that. You see right there, if 3 is here, x less than 3, see right there, 3 is not included. It goes that direction, okay? Alright. So we'll have 3, okay, negative infinity. You see there, that's how it goes, right? Because 3 is not included. Alright, that's it. That's number 11. Let's go to number 12. Number 12 is right there. Number 12, it says 3x minus 9 greater equal to minus 2x plus 6. Okay? So we kick that out. We kick that out, okay? So we'll move the like terms to the same side. Okay, so we say 3x plus 2x greater equal to 6 plus 9. You see it, right? And then it's 5x greater equals to, what is that thing there? Is 15, okay? X greater equals to 15 divided by 5. That will give you 3. Well, I don't want to confuse you because I know some of you, if you go, you can say 3 because you're going from there to there. So it's still x greater equal to 3. You see it, right? So don't get confused. Whatever you do in this side is that side business, okay? Alright. So you see that, right? This is number 12, and then we're done with that. We're done with, oh no, we're not done. We'll have to draw, sorry. We'll have to draw the thing. Where is 3? 3 is here, and 3 is included, and it's going in the positive, x greater than 3. So that's included, so you shade that like that, it goes that way to positive infinity. So that's 3 positive infinity like that. Sorry, you don't do that. You can't include infinity because you don't know where infinity ends. Okay, so like that. That's what it is, like that. Alright. Yeah, that's what it is, like that. So let's go to number 13. So we're on marathon here. Number 13 is there. Number 13 is negative 8x plus 1 less than negative 4x plus 11, okay? And then we'll have you solve that is negative 8x, you move things around, plus 4x less than 11 minus 1. You see, I move things over. If you move 1 to the other side, it becomes negative. You move negative 4x to the left, it becomes positive 4x. That's all I'm doing, man. That way we'll save time. Make sure you see that, so, and then what is that? You simplify, what you get? You get negative 4x, okay? Less than what is that in 10, okay? Alright, so if you gotta divide now by negative number, it reverses the sign of the inequality. Just make sure you keep that in mind. Alright? So once you do that, what do you get? You divide them by -1 to get, -4 to get rid of the 4 on the -4 on the left. You have x greater than, then it becomes -10/4 because you divide them by -4. So what is that? X greater than 2 going to 4. You have 5/2. You see that? Alright. Okay, so that's what we got there. Then we're gonna draw it. We're gonna draw that. What we'll have, if we have right here, we'll have -5/2. Alright? It's not included, so there's a hole there, and it's say greater than. So it's going from here to over there, and it's not included, okay? -5/2 is not included because there is a hole. So we'll write it like this: -5/2, comma, to positive infinity. That's what is you see there. You see, right? Make sure you see what is going on. So that's why I'm doing a bunch of this to help you to see what is going on, okay? So let's move to the next one, number 14. Okay, number 14, what is that? You read that there, right? It says -4y plus 12 plus 9y is greater than or equals to y plus 9 plus y. So don't let that confuse you. They're piling up y. When you move it to the same side, they cancel each other out. So don't let that look like it's too difficult. It's not difficult. Everything is still they're adding stuff. So what we're gonna do, we need to start subtracting stuff. That's all. So to move the variable to the left side, we'll do -4y minus y minus another y greater than equals to, you see that, right? On the right side you got 9. So we'll move from the left side, we'll move over. No, I dropped something. Hang on, I dropped something. I dropped -9, okay? We'll put it back. I dropped a positive y. Positive 9y, sorry. So we're gonna put that back. Plus 9y greater equals to, what is that? We got 9, and then we'll bring 12 to the other side. It becomes -12. Okay, you see that? I kind of dropped that off. You don't want to do that. So you take care of all that stuff. What do you have? You have -6y plus 9y greater equals to 9 minus 12. So we take care of, simplify both sides. What do you get? You get 3y greater equals to -3. You see that, right? So we haven't multiplied or divided with negative number. We didn't do that. So the inequality, or the order of the inequality, is preserved. So we say y divided by +3. Y greater equals to, let me see, becomes -1. I hope you see that. We didn't do anything wrong. We were just doing it carefully, moving on. You see that, right? Anyway, so that's what we got. So we'll have to draw it. -1 is included, so we'll say -1 here. We'll draw it here. And then it's included, we'll put the 0 here. So we'll have to shade it. We'll have to shade all that since it's included, okay? We shade all that in there. And then which direction does it go? Which direction does that thing go? Let me make sure you understand. This is give me a minute. Kind of messed up. It's like somebody took a bite out of it. This is -1 here, -1. So y is greater or equals to -1. So it's starting here, is going greater, going that way. You see that, right? And -1 is included. So you have -1 going to infinity. You see it, right? So, you can't just, if you don't understand it, just go through it, rewind the video, go back and forth until you understand it. Because this is actually very, very important. See, this idea of graphing this and then put it in this form. When you go to calculus, if you understand it, you will thank me when you go to calculus. All right, believe you me. When you go to calculus, you say, "Oh, I made a mistake. You can't do that. You can't do that." I just saw that. You don't include negative because you don't know where it ends. So when you go to calculus, you thank me for all that stuff. Being able to take an interval and represent it in drawing or put the drawing in the interval. That is very, very important in calculus. Okay? So let's move on. We'll move on to number 15. What is number 15? You see right there, that's another long one. But don't let that put you off. Because they're just piling it on to make you think it's too hard. It's not hard. It's just the way they wrote it there. They piled up a lot of junk up there. So now we're going to remove the junk from everywhere. So we isolate variable on the left, constant on the right. We say 14x plus 7x minus 10x. You bring it over. You change the sign. All right, greater than, we got 4 minus 10. We'll bring 6 over. Change this sign to plus 6. You see that, right? We haven't multiplied or divided by negative, so everything is preserved. All right, so we'll combine stuff on the left side, on the right side. So what is that? You will combine slowly. So 14 plus 7. All right, so that's 21x minus 10x greater than, what is this? 10 minus 10, okay? So you keep combining. When you subtract that, it would be, you do both sides, it would be subtracted, it would be 11x greater than 0. Okay, so then it would be x divided by 11 greater than 0. You see that, right? So we didn't do anything wrong. We just followed the rules, man, and then that's what we got. Do not overthink it. Whatever you get is what you get. So that's nothing to overthink. Okay, so we got that. And then we'll draw it. If this is 0 here, x is greater than 0. 0 is not included. So you draw that, it goes that way to infinity. And then it becomes, if you put 0 here, 0 not included, to infinity. That's right there. So how you read that is it's an interval from 0 to infinity. Right? That's how you read that, man. So 0 is not included, so you leave the whole there. So we'll move on to the next one. What is that? The next one is, we'll do a marathon here. Is that, you see how they did that? Don't let that throw you off, man. They just try to make it a little harder, but it's nothing. We've done this before. We've done other stuff before in the past. Okay, so you remove the bracket. After you remove the bracket, you move the right terms, the constant to the right, the terms with variables to the left. That's all. So let's remove the bracket first, okay? Then you have 7x minus 14, you multiply, is less than 4x minus 16 after you multiply that thing out. So what do you get? That's 7 here. So you move things around. 7x minus 4x is less than negative 16 plus 14. When you move 14 over, it becomes plus 14. You see that, right? Okay, so that becomes 3x less than, what is that? Less than, it becomes negative 2. You see that, right? So we divide by 3 on both sides. You will have x less than negative 2 over 3. See? We didn't divide by with negative, okay? So that's what we got there. We'll draw it. Okay, so this is negative 2 over 3 right there. It says it's less than. It's not included, so it goes that way. Because x is less than, okay? And then the interval is like that. If you have a negative on the right hand side, negative 2, 3, and then you don't include the intervals, it's negative infinity right there. You see it, right? Alright, see it. So you can have positive infinity or negative infinity. In this case, we'll have negative infinity because you go into the negative direction. You see it there, right? Okay. So this is very, very important. That's why I want to take my time and solve a lot of problems. So each time I solve, just watch what I'm doing until you get it. This idea of interval, representing interval like that, is very, very important when we get to pre-calculus and calculus, okay? If you master this, then when we solve problem, then you will understand. I'm gonna say something later on, but let's keep going. Okay, so that was 16. Let's do number 17. See number 17 there? So we're on marathon with this thing. Number 17 says that they just make it a little bit tougher, but it's okay. We can handle it. They can add whatever they want to add there. We can handle it. And then we multiply things out, okay? You just multiply, remove brackets, and then combine stuff. That's all you're doing, man. So 2y minus 10 plus 3y greater than 4y minus 24. You multiply 4 by 6 plus 1. You see that, right? All right. So we keep moving on. We'll move variable to the left, move constants to the right. We'll have 2y plus 3y minus 4y greater than minus 24 plus 1 plus 10. You see, we brought the 10 from the left side. You see what we did? Look at it carefully. You know, we did, when you move things over, it changes sign, okay? As long as you not multiply or divide it by negative, you're good. You leave the other the way it is, okay? The inequality sign the way it is. Okay, now you combine things, right? If you combine things, you have you can do it slowly. If you want, you can do it in your head. That's 5y minus 4y greater than negative 24. What did I do? Let me see. I think there's something, I'm missing something. Yeah, I kind of left something. Let me correct that before we make a mistake. I left something. That's why you have those two. I can see it. See, we left out 1. There's 1, there is 4, 24, there is 10. So that's plus 1 plus 10. You see that, right? So when we combine that, we'll have a plus 11. You see it, right? Okay. So let me check it one more time. Yeah. Okay, we're doing it right this time. So we'll say y greater than, what is that? Negative 13, right? Yeah, negative 13. That's all, man. We're done. Y greater than negative 13, then we'll draw it. We'll draw it like that. This is negative 13. Y is greater than it, so it's going this direction. And 13 is not negative 13 is not included. So you leave a hole like that. You leave a hole like that and go to the other direction, okay? Alright, so then that means it's negative 13 going to infinity, okay? From negative 13 to infinity. That's all that means, man. Okay, so let's go to number 18. You see number 18 there? It's you see what it says there, right? Again, don't be scared, man. They put a little fraction in there, and so what? We dealt with fraction in the past, so we can deal with it now. There's nothing to be scared of. So the first thing you do, you have to remove the brackets. Okay, first we remove the brackets. There is a trick to this. I mean, there are different ways to proceed, right? There are different ways to proceed, but you eyeball it, you can see stuff. You can multiply with a positive number both sides, or you can divide with positive number both sides. You can even divide or multiply with negative number, but just make sure you keep your eye on the sign. So what I'm gonna do, let's multiply both sides with 12. All right, so we'll say 12 times 5 over 12. Okay, 5x minus 7. You see that? It's less than. We're multiplying with positive though. So, and then you multiply the other side with 12. Okay, 5 over 6. And then x minus 5. You just want to see what you can do to make it simpler. That's all. So this cross out, you get 2 here. So it becomes 5x minus 7. You see that, right? Less than. That's all. Less than 2. Let me see. 6 cross out there. 6 divide there, you get, actually not crossing at 6, 6 divide 12. So 6 is still there. 6 divides 12, you get, so 6 is still remains there. Okay. Because no, actually 6 is not there. 6 went into 12, you got 2, sorry. So you get 5x minus 5. Okay, now you start simplifying. You remove the bracket. You get 25x minus, what is that? 5 times 7 is 35. Less than 10. Yeah, we gotta do that in 2 stages, because we don't want to get confused, you see. So we do the right side in 2 stages. That way we don't mess up. That's the idea. What will make you mess up, just keep going, keep simplifying until you're satisfied. You take as much time as you need, but of course if you're in the exam, you have to hurry up, but you don't want to in a situation where you make a mistake and you get the wrong information. All right. So we keep going. So that becomes 25x minus 35 less than 10x minus 50. See that, right? Okay, so now we'll move things around. We'll have 25x minus 10x is less than minus 50 plus 35. You see that, right? Okay, so what is that? That's you remove 10, that's 15x less than, what is that? 35 minus 50. What do you get? You get, that's negative 15. You see that? So all that stuff, all that torturing stuff boils down to 1. So you divide both sides by with 15, you get x less than. Don't forget that's a positive number, so nothing changes. Becomes less than -1. You see that, right? Make sure you see that, man. So we did it the best way we could to avoid a bunch of problems. You see, so that's what we got. X less than 1. We'll draw it. If we draw that in there, put less than. I'm sorry. X less than -1. You put -1 here. X is going the other direction. -1 is not included. You go that way. So that will be -1 to -infinity. See that, right? It's going to -infinity, but it's starting from 1. So starting from -1, it goes to -infinity. That's all that is telling you. So we'll move on to the next problem. Okay, so we're gonna be careful with this one. It looks like they put a bunch of fractions in there. Now you gotta eyeball it though. That way, it's like similar to the one we did before. You multiply by both sides by 9. You see, look at that. Multiply both sides by 9. 9 will go away. 3 will divide 9. See? So let's do that. Multiply both sides by 9. You get 7 like that. X minus 4 less than equals to multiply by 9. 4 over 3 x minus plus 5. You see that, right? So you keep doing it. This gets away. 3 go into 9, it gets 3. Okay, so then you say 7 x minus 4. You see that? You see what I'm doing now? Okay, we haven't done anything that warrants changing the direction of the inequality. So that becomes, you see, 3 times 4 is 12. So let's take care of that right now. X plus 5. You see that, right? See this 3 here. This 3 here times that 4 is 12. Okay, you see that, right? All right. Okay. So now we remove brackets. You have 7x. 7 times 4 is 28, right? 28 less than equals to 12 times 1. Okay, so what you got there is 12x plus 60. You see, 12 times 5 is 60. Okay, you see that, right? See how we simplified it? Because we just refused to. If you make mistake from if you do it the wrong way from here, you work with a lot of fractions. You just want to avoid that. At the end, you may end up with fractions, but it's okay. It's easier to work with whole number than to work with fractions. That's why I'm doing it like that. But you can do it any way you like. That's the way I like to do it. Okay. All right. So we keep going. Now we'll put the like terms, variable to the left, constant to the right. What do we get? 7x minus 12x. You see, right? Less than equals to 60 plus 28. You see, right? So we simplify. What do we get? We get, I think, negative 5x less than equals to, what is that? That's 88. You see, right? So negative 5x, when you subtract 7 from, when you deal with minus 12x plus 7x, you get minus 5x. Okay, so you divide both sides with negative 5. Okay, basically you're going like this: divide by negative 5 and divide here by negative 5. Okay, so that will have effect of changing the sign, but let me remove it with it because we want to show all the steps. Let's remove it. So I will go like this: negative 5 divided by 5x, and then we change the sign. it becomes 88 divided by -5. You see that, right? So this one will cancel out. You get x greater equals to -88 over 5. You see it, right? So that's what we got. You know, we almost took a lot of space. So let me draw I'll draw the diagram on the left side right there. You know, so that way everybody can see it. That way we can work the other problem, okay? So we'll draw it there. So what we'll have is right there. We can squeeze it in here. So you have right here -88 over 5, okay? And they say x greater than equals to. So that means that thing is included and is going this direction. So you shade that in, it's included. That point is included. Okay, so then you say like that. I'm sorry. Since the point is included, we need to include it like that. Okay. I'm making a mess, sorry. Okay, so you make it like that, -88 over 5, and then positive infinity. Okay, see right there. It never includes a positive infinity, like it's not going anywhere. It's still gonna go because we don't know where it stops. So anyway, so we did that one. So let's go to the next one. I wanna get this knocked out before I go to the application. There's application on this too. So we do that. What does it say? This is it says 6x 1 over 6x plus 1 over 3, then that bracket, then it's greater than half. Okay, so we'll proceed the same way we've been doing it. So we'll remove the bracket first. Okay, x over 6. You remember, I just rewrote that like that, so don't get confused. You see, it's another way to write that. I'm just putting x on top. Okay, and then I remove the bracket. It will be x over 3. You see that, right? Negative, let me see, is 1 over 3 is greater than what is that, half. Okay, so now we're gonna simplify. We're working with fraction now. First of all, let me move things around. X over 6 plus x over 3 is greater than half. You move -1 over 3 over, it becomes +1 over 3. Okay, so notice what is going on. We can use our trick here. We got a lot of tricks we know from the past. All right, so we're gonna get things in the same denominator. Okay, so how do we do this? Okay, look at it carefully. I usually say least common denominator. You know, least common denominator on the left is if you want to do that, another way you can do it, you say x, use our trick, x plus, you say 2, you multiply things by 2, x over 3, 2 times 2. You see that? That's another way you can do the least common if you want to. And then over here you do the same thing because you want to get them in the same denominator. Okay, so I can get those to 6. I can get them to 6 as common denominator. So we'll do 1 over 2. You see that, right? Because 3 over 3 will cancel out, it becomes 1. Okay, and then over here we'll do 2 over 2 will cancel out, it becomes 1. You see that, right? Okay, we're not changing anything, man. You know, this is our trick we normally use in the past. Now check this out. X over 6 plus 2x over 6 greater than, what is that? 3 over 6, right? Plus 2 over 6. You see it, right? That's why we had to do that way. We'll have the same denominator. All right. So now we can simplify 6. What is that? Is x plus 2x. Let me do all the steps. That way you can see, because some people, I think, if I jump, they don't see it. And then 6 in the denominator is 3 plus 2. You see it, right? And then we'll have 3x over 6 greater than 5 over 6. You see it, right? All right. You can even multiply both sides with 6. If you want to multiply both sides with 6, you multiply this side by 6, multiply that side by 6. What do you get? You get 3x greater than, we didn't change anything, greater than 5. And then it says x greater than 5 over 3. You see it, right? So kind of combines 2 steps over there, but it's okay. I hope you see what I just did. It's like you put a bunch of tricks to it, and then you keep going, and then you're not breaking any rules, okay? So you do like that, that's what you get. So we can draw this thing. We got space to draw it, no big deal. Let's draw it here. I'm sorry, 5 over 3. X greater than 5 over 3, write it there. It's not included, right? That's a hole there. Since it's greater, it's going that direction. So that would be like that. It's 5 over 3. Okay, positive, and that's that right there. And then we're done with the problem. You see that, right? And then we'll move on, because I want to get to application. This is the last one before we get to application. So let's knock it out quick. So you see what that is saying there? That's another long one, but who cares? We can deal with it. Yeah, we can deal with that. We just saw that type before. Now, we remove the bracket. Okay, just have to remove the bracket. You remove bracket on both sides, and then you simplify. That's all. Okay, so you say 2y minus 4y minus 3 greater than 6y plus 3y plus 12. 3 times 4 is 12. Now, I know some people will get confused here. It's like there's a negative, it's negative 1 was used to multiply that bracket. So when you say negative 1 times 4y, you get negative 4y. You say negative 1 times positive 3, you get negative 3. See? In case you don't see that, that's what I did there. Okay, so now you move things around. Okay, 2y, negative 4y, negative 3y. Oh, I'm sorry, I missed one. Negative 6y. You see that? Greater than 12. Bring 3 over plus 3. You see that, right? Okay. So we got a bunch of y's on the left. So you combine them. So let me make sure we did it right. I think we did everything right. Yeah, we did it right. So you combine everything. What do you get? Okay, notice that all that combines to 2y minus 13y greater than, what is that, 15, okay? So we'll finish off with the left side. We'll get negative 11y greater than 15. Okay, so this time we gotta divide by negative 11 to get rid of 11 on the left side. Then the sign will have to change. The direction of the inequality will have to change. So then we get y less than, okay, y less than 15 over negative 11. You see that, right? That's what we did, man. So it's the same thing as a negative 15 over 11, okay? So basically y less than negative 15 over 11. That's what we got. See it right there, right? So we can draw that. It's a strict inequality. So I hope you see the word I use, strict. Strict inequality. It means when it's like that or like that. But if it's not strict, then it contains that. It contains that, okay? So don't worry about that. Let's see. So how do we draw that? We'll go like that. Negative 5 of 15 over 11. Okay, so it's less than negative 15, less than negative 15 over 11. So it's going, it's not included. It's not strict. So I'm sorry, strict inequality. So it's not included. Strict means less than. Okay, so it goes from there. So that thing, the point is not included. So it's gonna be negative 15 over 11. Okay, negative infinity. That's what it's gonna be. I hope you can see that. I think I know I did it right. You see it, right? So I'm done with this. Let's go to application. I think I'm done with it. I did a lot of examples to show you what is possible. Let's go to application, okay? All right, folks, we're gonna do a lot of application problems, okay? See the first one. They say Mary has grades of 94 and 88 on her first two calculus tests. What possible scores on a third test will give her an average of at least 90? An average of at least 90. You see that, right? So basically she took two tests, and then they said the third test, what will she get in the third test to get an average of 90? Basically, this is first you start with what you're looking for, okay? You always start with what you're looking for. I say let x be Mary's score on third test, okay? On the third test. Alright, on third test. Okay? So that's what you're looking for. Because you're looking for the score. The possible score on third test that will give her 90, okay? Okay. Then we're gonna do this kind of problem a lot when we get into statistics and probability, okay? You know how you calculate tests, you take average, right? You gotta take average. In fact, they use the word average there, see, to give her an average of 90. In other words, what they're saying is, they're saying at least. See, that word is at least tells you it has to do with inequality. At least means it can be 90, it can be 91, it can be 92, it can be 100. Okay, so it starts from, at least means actually, it's, let me see, at least means greater or equals to. So it can be 90, 91, it can be anything, it can be 100, okay? So when you see at least, it means greater than, equal to, okay, 90 or more than that. Okay, so if x is her score on the third test, then if you take average of the test, it will be 90, let me see, 94, actually it will be 88 plus 94 plus x. Oh, you divide by 3. Like I said, you'll learn that when we go to statistics. They say it's gotta be greater than or equals to 90. You see that, right? That's all they want you to solve, man. So once you read it, understand it, and set it up, the rest are easy. We'll solve this kind of stuff, earlier today. Okay, so once you get that, you set it up, it's easy. The rest are just what we've been doing. So you multiply, let me see, divide both No, multiply both sides by with 3. You get rid of that 3 over there on the denominator on the left. Then you get 88 plus 94 plus x is equals to, greater or equals to 3 times 90. You see that, right? You multiply, the left side with the 3. That's what you get. Make sure you understand that. You gotta go step by step. That way you can understand what is going on. Once you understand what is going on, the rest are easy, man. But if you don't understand it, then it will be difficult to solve. So if you do all that, it will be basically let me see, 88 plus 94 plus x greater equals to 270, okay? And then you move stuff around. You have x greater equals to 270 minus 88 minus 94. You see that, right? So you do that, you get x greater equals to what? You subtract 88 from 270, and then you subtract 94 from 270. What is left is 88. Okay, if you do all that, what she needs to get is 80 or over. She can get 88, 87, 80, 89, and 100. So in order to get at least 90, to get at least 90, an average, yeah, an average of 90, okay, in the test, what they say, an average of 90 in the third test. Okay, she needs she needs no, hang on a minute. What possible score on the third test will give her? Okay, to get at least to score. Oh, to get at least an average of 90, right? Okay, she will need she will need, okay, she needs about 88 or more. 88 or more, okay, on the third test, okay, on the third test. Okay, we're done with that one. Let's move on to the next one. That's all they want there. You see the next one, it says, if 9 times a number is added to 6, the result is at most 3. Find all such numbers. See what they're looking for there. At most, you see, when you see at most means you can get to it, but less than or equals to. At most means less than or equals to 3, okay? That's the way. So I'm glad we're doing this problem. See, over here is at least. Where is that? At least 90. Okay? At most 3 means less than or equals to 3, okay? So how do you say that? You say let x be the number. Let x be, because you see this is our q here. Let x be the number, okay? And then it says 9 times a number is added to 6. So it says 9x plus 6 is added 9 plus 6, right? 9 times a number, 9 times x plus 6 is at most right there. See, that's why the inequality comes in. The result is at most right there. See? Once you set it up, the rest of the stuff are the rest of the stuff are are easy to solve, but you gotta set it up. You gotta set it up first, okay? So once you set it up, you find such number. We're looking for that x. So we'll say 9x. We'll proceed the way we've been doing it. Less than or equals to let me see, 3 minus 6. You move 6 over, okay? Then you say 9x less than, you get negative 3, sorry. Negative 3. Alright? So then you divide both sides with 9. You get x less than equals to negative 3 over 9. Notice that that is negative 1 over 3. You see that, right? You see that, right? So result, okay. 9 times a number is added to 6. The result is find us. Okay, the number x. Let me see. Well, the way you say, be careful how you say it. The number we're looking for is the one we got is x less than or equals to negative 3. So numbers less than or equals to negative 3 will satisfy it. That's all. That's all that is said. Numbers, because we said let it be such a number. Numbers less than or equals to negative 3 will satisfy whatever is given here, okay? Whatever given in the problem. So we'll leave it like that. So let's go to the next one. The next one says the perimeter of a certain square cannot be greater than 200 meters. Find the possible values for the length of a side. Perimeter of a certain square. Remember we talked about perimeter before? Perimeter of a square. You can almost get that without, you can think that out. Let me show you how. Perimeter of a square. Perimeter is you go around. Square has see they give you side here S. This is S2. This is S2, and that's S. Okay, they give you perimeter. Perimeter is you start from here, you go here, you go here, you go here, you end up here. So you have to add those 4 sides. So perimeter of that is equals to S plus S plus S plus S, which is equals to 4S. You see how they got that, right? Perimeter is walking around. I'm walking around that thing. Alright, say the perimeter of a certain square cannot be greater than 200. So what they say in their perimeter cannot be, see, cannot be greater than 200. What is that? How do you translate that? Cannot be. In other words, if it cannot be greater than 200 meter, that means it can be, let me see. You gotta be careful with the language, man. Like I said, the word will get you. You have to try to understand what are they saying. You see what I'm saying? What are they saying? Perimeter cannot be, less than. Alright, sorry. I think I'm getting things mixed. Okay. So, basically what they're saying there, when they say cannot be greater than, so that means it can be 200 meters, but it can be less. You see that? So that means it can be 200, it can be less. That means 200 meters. It cannot be greater than. So that means it can only be 200, but it can be less. That's all that is saying. So he's saying it can be 200 or it can be less. You see, that's what that represents right there. Okay, so the perimeter is 4S. They say less than equals to 200. Okay, that's all you're looking for. You solve that. You leave S on the side. On the left side, you get 200 over 4. Perimeter, S, the side, not perimeter. S less than equals to, divide that. What do you get? 4 divide 20. You get 5 and then 0. That's 50, man. So the length of the side has to be 50 meters or less. See, that's what it says here, 50 meters. The side has to be 50 meters or less. You see, I hope you're picking up something from there, because that's what that says right there. That's what that says, 50 meters or less. It can be 50 meters, but it can be less. That's all he's saying, man. So let me see if I have another. Yeah, I do have one more, but it's not one more. I got tons, So let's deal with this one, and then we'll go to the rest, okay? All right. This one says, it says that another grade. Lucy has grades of 76 and 81 on her first two algebra tests. If she wants an average of at least 80 after the third test, what score may she? It's the same thing she make on the third test. That's the same thing we did before. It's the same thing, okay? So what score will she make on the third on that test, which is the third test? Okay, so we'll say let x be score, okay, on third test. Same thing, we did that before on third test, okay? All right, so they say she got 76 and 81. If she wants an average of at least, you see where that comes in, where inequality comes in. So that would be 76 plus 81 plus x will be at least, that's greater than equals to 80. At least means, remember we talked about that earlier in the first problem, at least means it can be 80 or it can be greater. It can be 80 or it can be greater. 80 or greater. Okay, don't forget we're looking for the average of the grade. So all that stuff will be, it will be 76 plus 81 plus x over 3 greater or equals to 80, okay? Alright, let's solve that thing out. And then what do we have? We'll do the same thing we did before. We'll multiply both sides with 3 to get rid of 3 right there on the denominator, okay? And then we'll get 76 plus 81 plus x greater equals to 3 times 80. See that, right? Alright, so you see that 3 times 80 is 40. Alright, I'm sorry, not 40. 3 times 80 is 240. Yeah, 3 times 80 is 240, okay? So then we'll just keep going until we don't make mistakes. 76 plus 81 plus x greater equals to 240. Okay, and then we'll start moving things to the other side. We'll have x greater equals to 240 minus 76 minus 81. Okay, you see that, right? Okay, when you subtract out those two numbers, you have x greater equals to 83. Okay, that's what you get. So then that means, what does that mean? That means that her grade on the third test, right, on test number 3, her grade on test number 3 will have to be 83 or greater. That's all that means, man. Her test. What's her name? Lucy's test. Lucy's grade on third test, okay, has to be 83 or more. That's what that is saying, man. Okay, that's what that is saying. So let's move on to the next example. All right, let's look at the next one. It says a student has scores of 87, 88, 95, and 79 on 4 quizzes. What scores may she make on the 5th quiz to have an average of at least 85? You see, we've done a lot of this, but you see now it has more quizzes. 1, 2, 3, 4. It has 4 of them, and the 5th quiz they want to know what she has to score to get at least. So always pay attention to the language, at least 85. So basically what they're saying, like we did before, you can say let x be her grade, okay? Her grade on quiz number, what is that, number 5, okay? Quiz number 5, okay? And then you see from what is given, you say 87 plus 84 plus 95 plus 79, okay, then plus x. That would be 1, 2, 3, 4, 5 divided by 5, you see, because when you average you gotta divide by the number you added. Okay, say for her to make an average of at least 85 means 85 or more. 85 or more right there. Okay, so that's what they're asking. That's what you gotta solve. You solve that, then you're home free. So let's solve that quick. Let us solve that. Again, we'll multiply both sides with 5. We get 87 plus 84 plus 95 plus 79 plus x greater equals to 5 times 85, okay? So what do you get there? That's what they're asking for, man. Okay, so notice that if you multiply that out, you get 425. If you add the 4 grades, you get 345. So basically we're doing, let me see, 345 plus x greater equals to 425. You move 345 the other side, you get x greater equals to 425 minus 345. Okay, that's all you're doing there, man. You know, because when you move 345 the other side, it becomes minus, okay? So when you do that, you get 80. Let me see. So x greater equals to 80. That would be her grade on the 5th quiz. So her grade on the 5th quiz has to be 80 or more. That's all they need there, man. So we'll move on to the next problem. Alright, let's look at the next example. See what it says. The average monthly precipitation in Houston, Texas for October, November, December is 4.6 inches. They gave you the average, just like they give you the average in grades. Remember, we just finished the grade one. And then it says, if 5.7 inches falls in October and 4.3 inches falls in November, how many inches must fall in December so that the average monthly precipitation for this month exceeds 4.6 inches? See that? Pick up on that. Exceeds means greater than. Okay, and then you giving two numbers, and then the third one, and they give you the average. The average is there. So it's like the grade thing, the what we did in grade. So we are looking for December 1. So what you need to say, let x be the amount of precipitation, okay? Precipitation in December, because you're giving November, October, but you're looking for December, okay? All right, so you giving 3 and you giving 2 and you giving the average. So it's like the grading. So you giving 5.7 for October plus 4.3 for November, and you don't know December. That's why we put that X. And the average is 3 numbers, right? And they say it's greater, not exceed, means greater than 0.6. That's all. So you gotta solve that. That's all you need to do. We'll solve this kind of stuff before. You just multiply both sides with 3. You get 5.7 plus 4.3 plus X, okay? Greater than 3 times 4.6. That's all. You see that, right? Okay, when you add, when you add those two, you get 10.0. When you multiply this out, you get 13.8. So you say 10.0 plus X greater than 13.8. You move things over. You say X greater than 13.8 minus 10.0. If you subtract that, what do you get? You get X greater than, what is that, 3.8. Okay, so that's what they're looking for. Okay, so that means more than 3.8. That's what that is. More than 3.8 precipitation. Yeah, there will be more than 3.8 precipitation. Okay, precipitation in December. For the condition to hold, there has to be more than that. Okay, so that's what they're saying. So we're gonna move on to the next one. Let me get the next one ready. This is the next example. It says when 2 is added to the difference of 6 times a number and 5, the result is greater than 13 added to 5 times the number. Find all such number. Well, so when you see this greater than, you know it has to do with inequality, okay? But something like this, we did a lot of this in the past. First of all, you say let X be the number we're looking for. Be the number. You take your clue. 2, when 2 is added to the difference of 6 times a number. Let X be the number. The number, okay, we're looking for. And then you start doing stuff they say due to X. When 2 is added to the difference of 6 times a number. Difference of 6 times a number and 5. So that means 6 times X, the difference of that plus and 5. And they say when 2 is added to the difference, right? So that you add 2 to the difference, okay? And then it says the result is greater than 13 added to 5 times that number. Greater than, again, they're doing something to the number. 13 added to 5 times that number, 5 times the number, and 13 added to it. You see that, right? That's what they're saying. So sometimes it's tongue to wisdom, but if you read carefully, you get that. So that's what they want you to solve. So you remove bracket 6x minus 5 plus 2 greater than 5x plus 13, okay? Alright, you move things around. Notice that 6x minus 3 greater than 5x plus 13, okay? You move things around, you have 6x minus 5x greater than what? 13 plus 3, okay? So if you do that on the left and do that on the right, simplify, what do you get? You get x greater than, what is that? 16. That's all, man. That's all. So they say find also, of course, any number greater than 16 will do. That's all that is saying. Any number greater than 16, is short number will do the trick. So let's move on. We're done with that, man. There's no need beating on the dead horse. So let's go to 29. We've done a lot of problems today, man. Okay, when 8 is subtracted from the sum of 3 times a number and 6, the result is less than 4 more than the number. Find all such numbers. It's the same thing. It's the same thing, man. Okay, it's the same thing. They're not telling us anything new. So we'll start the way we normally do. Let x be the number, okay? Be the number they're talking about. Let x be the number, right? Then you see, start doing what they said they did to x. When x is subtracted from the sum of 3 times a number, sum of 3 times a number and 6. So sum of 3 times a number, 3 times x plus 6, and the 8 is subtracted from it. You see what they're saying? That's what they're saying there. I hope you get that. And then they said here is the word equality. The result is less than 4. The result is less than 4 more than the number. What is 4 more than the number? 4 more than the number means the number plus 4 more than the number. That's all that means, man. So you just solve that. We've seen this before. You just have to set up this. If you set up what they're asking you to set up, and then you solve it, and you're done. So let's remove bracket. We have 3x plus 6 minus 8 less than, what is that say? Less than, yeah, less than x plus 4. Okay, you simplify things, man. That's 3x minus 2 less than x plus 4. Move things around. 3x minus x less than 4 plus 2. Simplify, you get 2x less than 6x less than 6 over 2. Okay, what is that? That's 3. So basically x is less than 3. That's all. That's all they want, man. So all number that is less than 3 will satisfy, will fit, will fit the bill right there. So we're done with that, man. Let's move on. That way we can finish. It says the formula for converting Fahrenheit temperature to Celsius is C equals to 5 over 9 in bracket F minus 32. We've seen this before. Then it says if the Celsius temperature on a certain winter day in Minneapolis is never less than that. Never less than. See, pick up on that. Never less than that. So that means never is never less. Never. Okay. You gotta be careful with the word, man. The word will get you. That means never less than that means always greater than that. Always greater than. That's all that means. 25 degrees, okay? How will we describe the corresponding Fahrenheit temperature? Okay. So be careful. You gotta understand what they're asking. That way you don't make mistake. Okay, if you don't understand what they're asking, then you're gonna end up making mistake. So this is what they're saying. It says, let me see. If Celsius temperature on certain is never, okay, Celsius is never, that means it's never that. That's all they're saying. Celsius is greater than that. Okay? So if that's the case, how will we describe the corresponding Fahrenheit temperature? If Celsius is always greater than that, right? Then what is Celsius? So actually see right there, Celsius there. So that means, so you gotta be able to understand, see what they're saying. F minus 32 is greater than minus 25. That's all we gotta solve, because you see, that's the key right there. So we'll solve that. The trick is to multiply both sides with 9. You get, if you do that, you get 5f minus 32. If you multiply by 9, multiply by that, it knocks that thing out. Okay, and then you gotta multiply by 9 on the right hand side. 9 times, okay, 25. Okay, so if you do that, what is going on there? If you do 9, okay, so that's what you get if you multiply that. But I gotta also do the left. 5f minus what is that? 5 times 32. You see that? You multiply 5 with 32. What do you get? You get 160. Okay, 5 times is greater than minus 225. Okay, and then you gotta move things around. You say 5f greater than minus 225 plus 160. When you move 160 on the side, it becomes plus. Okay, you see it, right? I mean, there's no magic there. We're just doing what we know how to do best. Okay, just keep moving things around. Then you get 5f greater, because this is greater than that. It's greater than negative. What is that? Yeah, negative 65. So you divide by 5. 5 greater than negative 65 divided by 5. If you divide that by 5, what do you get? You get equals to negative 13. You see that? That's all they want, man. So f will have to be greater than negative 13. That's what they want right there. I hope you see that. That's all they want, man. Well, did I make a mistake? What is that? Hang on a minute, let me see something. I think there's one little mistake I made, because it says it's never less than. What does that mean? It's never less than means it's greater than, or it can also be negative 25. So sorry about that. We'll have to put this here, less than or equal to. Just go back and put it there, because I think I misread that. You see, you gotta be careful with the signs, man. Never less than means greater than, okay, or greater than or equals to, because 25 is included too. So that's the only mistake I made. I corrected it, and then the temperature they're looking for, is that. So it's never less than or greater than 13. That's all. Let's move on to the next one, man. Let's not beat a dead horse. So what is this one here? It's the same thing. The formula for converting Celsius temperature to Fahrenheit, you see, it's almost the same thing. The Fahrenheit temperature of Phoenix has never exceeded. Never exceeded. I hope I don't make the same mistake again. Never exceeded means it's 122 degrees. Never exceeded or less. Is that or less? That's all that means. How will we describe this using Celsius temperature? You see? How will we describe that using Celsius temperature? See what he's saying there? So I hope I want to do this one. I was going to skip it, because since we did it wrong, but it's good. That way you understand. I made that mistake before. I'm not going to make it again. Has never exceeded. He said it can be 122, right? But it's never more. So it can be 122 or less. That's all that is saying, man. You hear me? That's all that is saying. You know, so once you understand that, you gotta just really careful, make sure you understand that, you know, and then you see. And then what is the Fahrenheit temperature? Never, it says Fahrenheit. That's Fahrenheit right there. So what they're saying is F is always 22 or less. I mean 122 or less. That's all. And you're giving that there. So it's 9 over 5C plus 32. You see, never less or more. I'm sorry, less than or equal to 122. See that? That's what they're saying there, man. So you need to understand that you just need to solve that. That's all. Once you solve that, you get the. Hang on a minute. Yeah, you get the temperature in Celsius. Yes. Okay. So how do we proceed? 9 over 5c. Let's move the other thing. Let's move that to the right side. We get 122 minus 32. What is that? What is 122 minus 32? So we gotta do that first. That way we'll make things easier for ourselves. Okay. Okay. That if you do that, you get 90. So basically, we'll say 9 over 5c less than or equals to 90. Okay. We'll get rid of 5. We'll say 9c less than, we multiply by 5. 5 times 90. See that, right? Because it's like we multiply both sides with 5 to get rid of 5 on the left. You see that, right? Okay. So it will be 9c less than or equals to 450. Okay. Then c less than or equals to 450 divided by 9. What is that? You divide that by 9, what is that? It's 50. So basically what they're saying is c less than or equals to 50. That's what they're looking for. So that's what they're looking for. So the temperature in furnace would never, well, it's always less than 50 or less, right? So that means it will never exceed 50. So it can be 50, but it can be less. That's all that is saying, man. So you see how useful this thing is, depending on what you're thinking about. Let's go to the next example and knock it out. Okay, it says that now we're dealing with, for what value of s will the rectangle have a perimeter of at least? At least, you see that? At least means it will have that, or it will be greater. That or greater. So both that or greater. See, that or greater. So what is the perimeter? The perimeter is you walk around that thing, right? If you start here, you go and come back. So obviously it's 2 of these and 2 of that. So perimeter would be 2. Let me see. Perimeter would be 4x plus 3 plus 2x plus 37. You see that, right? That's the perimeter. But it says the perimeter will never have to be at least. So that means 4 plus 3 plus 2x plus 37 greater or equal to 400. That's all they're saying there. If you can solve that, then you're done. You see that, right? Yeah, if you can solve that, you're done. We'll solve something like this before. The thing is, you have to read it, understand what they're saying, and then you set up the equation, and then you go. So you remove the brackets. What you get? 2. Let me see. Sorry, I'm just gonna do it quick. 2 times 4 is 8. 2 times did I miss something? I think I made a mistake. I'm sorry. 4x. I thought I missed something. Sorry about that. Let's see. I didn't put 4x, man. See, you gotta be careful. I'm glad I caught that on time. Okay. X plus 37. Okay. So that would basically be 8x. Yeah, I thought something was missing, because you can't write that the way I wrote it. Plus 6 plus 2x plus what is 37 times 2? All right, you gotta find 37 times 2. What is that? It's 74. 74 greater than or equal to 400. Okay, and then you collect the x. to the left, you get it, and then you move the other one over there. 8x plus 2x greater equals to 400 minus 6 minus 74. That's all. So you gotta simplify that, man. That's all. Okay, that's 10x greater equals to, what is that, 320, okay? So x greater equals to 320 over 10. And it will cancel out. That's a 32. Okay, so what are they asking us? So for what value of x? So x has to be greater or equals to 32 for that condition given us to hold. You see that, right? X has to be 32 or more. Okay, so we're done with that. It's nothing there. We don't overthink it. See a similar problem, okay? He says that for what values of S would the rectangle have a perimeter of at least 72? You see the same thing, at least 72. That means 72. I'm sorry. That means 72 or more. So that can be represented like this, greater 72 or more, like that. Yeah, 72 greater than something, okay? So the perimeter, what is the perimeter of a rectangle? I mean a triangle. You know, we talked about this before. Perimeter of a triangle, usually they're supposed to give you this, but yeah, they're supposed to give you this in the exam. The perimeter of a triangle is like this: A plus B plus C. You know, where this is A, this is B, this is C. You know, but you see the way they gave it to us. All right, they say, well, don't forget perimeter. So you start here, you walk over there, and you get over here. But you see, A is that, B is that, C is that. So you don't have to work with the A, B, C. Okay? So basically what they're saying is perimeter, you see, you add that. It has to be, what is that? You have to think of this, right? Perimeter has to be, does it have to be less? Hang on a minute. For what value of S with triangle have a perimeter of at least? Perimeter has to be, hang on a minute. Perimeter has to be at least. No, I got it wrong. That's not my thinking. It has to be this. It has to be that or more. I'm sorry. It has to be that or more, okay? At least. So that means perimeter has to be like that. Perimeter has to be 72. I'm so, what is wrong? 72 or more. You see that, right? It has to be 72, at least 72 or more. So basically P gotta be like that, 72 or more. It can be 72, but it can be more. That's what it means by at least. So how do you get perimeter? I say x plus 11 plus 2x plus 5. See, I'm adding all that. I'm adding that, and adding that, okay? And then it has to be greater or equals to 72. That's all. Once you set it up, the rest are easy, okay? And then you remove brackets. You have x plus 11 plus 2x plus 5. Let me make sure I copied everything right. Yes. Then what is that? That is what is that? Is 2, 3, 4. It's 4x. That and that. 4x plus 16. Okay, greater equals to 72. So it's 4x greater equals to 72 minus 16. You see that, right? You know, so make sure you see what I'm doing. You know, that I do it the way I do it. So if you take 72, you minus 16, you remove 16, what do you get? You get 56. 4x greater equals to 56. And then x greater equals to 56 divided by 4. What is that? If you divide 56 by 4, you're gonna get 14, okay? So it's x greater equals to 14. That's what we're looking for. For that perimeter, for that triangle to have a perimeter of at least 72, x has to be 14 or more. That's all. That's all that is saying, man. It's not saying more than that. Okay, that's all that is saying. It has to be 14 or more, okay? Yeah, the value of x has to be 14 or more. And then I'm done with that. Let's move on to the next one because I want to finish this. It's getting a little late there. Okay, so let's get this one. We have done a lot of problems, so we're gonna be proud of ourselves, man. Okay, so this is let me see, what is this? A phone call costs $2 plus 30 cents per minute, or fractional part of a minute. If x represents the number of minutes of the length of the call, then 2 plus 0.30 represent the cost of the call. If Alan has $5.60 to spend on a call, what is the maximum total time he can use the phone? Maximum total. So maximum is maximum total he can use the phone. So when they talk about maximum total, it means, think clearly now, it will mean total time. That is t is time. It has to be that plus that. So they said, what is the maximum total time he can use the phone? The maximum total time is actually t. If t is that time, it will be t will be equals to that time or less. Alright, t will be that time or less, whatever that time is. It will be that time or less. That's the maximum. You can't go over it. It's t has to be x or less, okay? So if you set that up properly, you gotta think through it. That's all. You set that properly, it will be a phone call costs, let me see, basically a phone call costs this plus that per minute or fractional part of it. If s represents the number of minutes of the length of the call, then represent the cost of the call. Okay, they want to know if Alan has 6 hours to spend call, what is the maximum time? Okay, so basically what they're saying is you take that 2 plus 0.3 x has to be less than or equals to, yes, see, it has to be less than or equals to 5.60, okay? He can't go over that. It can be it or it can be less. That's all they're saying, man. So you gotta solve that. I don't know how you, it's a bunch of decimals, man. What you could do, say 0.3x less than equals to 5.60 minus 2. Alright? And then you say 0.3x less than, yeah, this, when you're working with decimal, it can be a little, it's not that big deal, but you gotta just, use what we learn from arithmetic, right? Okay, 5.6 minus 2, you get 3.6, okay? And then basically x is less than or equals to 3.6 divided by 0.3. That's all. You see that? That's all. But this time, if you wanna, you can change that into fraction instead of decimal, but so we can knock it out quick. That is, this is equals to 12, okay? Yeah, it's equals to 12, man. So that man called Allen has to, if he has $5.60 to spend on call, the maximum minutes maximum total minutes he has to use the phone is 12 or less, man. Maximum, that means 12 minutes or less. That's all he has. Maximum is that. He can't go over it. Okay, so let's do the last one and then we'll call it quit today. This is like say at the Speedy Gas and Go, a car wash costs $3 and gasoline is selling for 3.60 per gallon. Carla has $48 to spend and her car is so dirty that she must have it washed. What is the maximum number of gallons of gasoline that she can purchase? You see the same thing, maximum. She can buy that. She can buy it unless and still, still wash her car. You see, that's what they're saying there, man. You see, so how do we tackle that one? So the amount she gotta spend, so she spent that on car wash, right? She spent that on car wash, right? And she spent this per gallon. We want to know how many gallons she can buy. Okay. So, you see, the trick is let X be number of gallons, okay, that she can buy, number of gallons, okay, that she can buy with the money she $48, right? So what they're saying is $3 plus 3.660x, because that's the amount of this is the amount of gallons, x is the amount of gallons. It can, what they say, what is the maximum number of gallons of gasoline that she can purchase? The maximum then she can purchase is, maximum means she can buy that amount or less than equals to, so she can buy it, she can buy that amount. Oh, you see that she can buy that amount, she can buy whatever amount it is, she can buy it or less. She can't buy more than that. So basically that is saying this is what she can spend because she got that 48. So it can be 48 or less because that's all she has, right? So this is what she's gonna spend on the car wash. Then she gonna buy this of gasoline, right? This is the number of gallons, right? If you add those together, it can be 48, but it can be more. It has to be less. So either it's less or equal to 48. That's how you say. It's kind of a little confusing. So you gotta solve that. You solve that, you get 3.60x less than equals to 48 minus 3. 3.60x less than equals to, what is that, 45? Okay, that's all. Basically, to get rid of that, you divide by 3.60. Then you say x less than equals to 45 divided by 3.60. Okay, so when you do that, what do you get? You're gonna get you're gonna get 12.5. okay, that's gallons. So it's x less than or equals to 12.5 gallons. She can exceed it. She can get 12.5 or less. That's what that is said. 12.5 gallons or less. That's what she can buy. Right? That's what she can buy. She can buy less and keep some money, or she can buy that, then her money will be exhausted. That's what that is saying. Please like and share this video. Subscribe to my channel. Leave comments or questions under the video. And then thanks for coming. I will see you in the next video. Okay? Thanks.